This is Unit 3, Chapter 8.1, the Prep Packet Exercises. Let's start with some notes. Our objective today is to talk about rational expressions and how to get them into lowest terms. One thing I want you to realize that a rational expression is a fancy word for saying a fraction. So when we need to get a rational expression or a fraction into lowest terms, you're just reducing it. And that's something you're pretty good at and you've been doing for a while. For instance, if I have 6 over 8, I can reduce that to 3 over 4. And the reason that works is because 6 is the same as 3 times 2, and 8 is the same as 4 times 2. And once I factor that out, you can see that hiding in there is a 1. And we can cancel that out. And that's why 6 over 8 equals 3 over 4. When I'm working with these kinds of fractions, it's always best to see if I can reduce vertically, and if not, maybe I can go across. Keep in mind, too, that you can only divide by factors, not by terms. So here, x plus 5 and x plus 5 are factors because they're being multiplied by 6 and by 2. Just like this 2 canceled out, that x plus 5 cancels out. That leaves us with 2/6, which reduces to 1/3. This is not true. Sometimes people make the mistake of trying to cancel that and that out, and that doesn't work. Again, that is an error that I don't want you to make. Let's work on some problems here to kind of get our feet wet. This first one, 48 n to the 8th over 4 n to the 4th, we can do some factoring. This is the same as 4 times 12 times n to the 4th times n to the 4th. If you want to remember, if you are multiplying with exponents, that's the same as n to the 8th, because 4 plus 4 equals 8. In the denominator, I have 4 times n to the 4th times a secret 1. So here I get to do some canceling. That makes 1, that makes 1. So when I'm done, I have 12 n to the 4th over 1, which is the same as just 12 n to the 4th. Let's take a look at this problem over here. There's some factoring involved. Like I say, I'm going to take care of one part and then worry about the other. So first let's attack the numerator. 28x squared minus 7. I can factor out 7, and that'll leave behind 4x squared minus 1. And here's where you need to be kind of on your toes, because I want you to notice that that is a difference of squares. So it's really 7 times 2x plus 1 times 2x minus 1. Again, be on your toes about that because it can really make a difference. And then just to reiterate, we have 6x squared plus 9x minus 6. Now, I can do some work here. First of all, to make it easy on myself, they all have a common factor of 3, so I'm going to pull that out. And I'm left behind with 2x squared plus 3x minus 2. Now, here we're going to do a little factoring. 2 times negative 2 is negative 4. The factors of that would be positive 4 and negative 1, because the difference between those is positive 3. So I'll have 3 times 2x squared plus 4x minus x minus 2, and then 3 times 2x times x plus 2 minus 1, and here be careful, x plus 2. Because remember, pulling out a negative out of a negative leaves behind a positive. So that's going to be 3 times 2x minus 1 times x plus 2. And now let's wrap it all up and see what we've got. From here, I have 7 times 2x plus 1 times 2x minus 1 over 3 times 2x minus 1 times x plus 2. That won't cancel, that won't, but this will. And what I'm left behind with is 7 times 2x plus 1 over 3 times x plus 2. And now I'd like you to stop and copy. And while you're doing that, I'll go on. Okay, let's try number 5. And I'm sorry these are not numbered well, but the problems correspond on your pages. So here I'm going to handle the numerator. So the common factor there would be 3 times m plus 6. And on the bottom, I have 5 and I have m. So 5m times m plus 5m goes in 6. And that one was pretty easy. M plus 6 cancels, and that leaves me with 3 over 5m. That one was pretty straightforward. This next one we have some factoring to do, so let's take care of the numerator first. I might be able to do this in my head. Let's see. Factors of 28 are 4 and 7. 4 plus 7 is 11. So that was pretty easy. So z plus 7 times z plus 4 over. And here's z plus 7. 7 times 7 is 49. That's a perfect square, so we'll do this. So that's going to be z plus 7 times z plus 7. Normally I would write that as z plus 7 squared, but I have some work to do. Those two cancel out because they make a 1. And that's going to leave me behind with z plus 4 over z plus 7. And that's the answer for that one. So again, you're going to stop and copy.